David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. All right, let's go over the calculation for finding out the hideout tree radius when the orchard is just 2 units big. So we start small, but in order to solve the orchard hideout problem, we are going to need to do a very similar calculation for an orchard that has a 50 unit radius. And we don't know the length of the unit yet, so our answers are just going to be in units. All right, so let's get started. First, I want to orient you to the drawing. So here's my drawing. We've been doing this in class for quite some while. This is a top view of the orchard. We're looking down. The X marks the center of the orchard, and all the dots are places where trees are growing. And remember, we had an important simplifying assumption for this orchard. The trees are essentially cylinders that are growing straight up, and the cylinders get bigger and bigger in diameter as the trees get bigger. There are no branches that obscure the view. So the orchard becomes a hideout when all the trees have grown big enough to block the last line of sight out of the orchard, okay? Finally, the other thing is that I'm only drawing this quadrant. This is quadrant 1 on the coordinate plane, and we do all of our analyses here because then all the numbers are positive. It makes the calculations easier, and we can do this because the other 4 quadrants, quadrants 2, 3, and 4, are identical to this one. The coordinate points just have negative numbers. So we can solve this entire unit problem just by looking at quadrant 1. Okay, let's get started. So figuring out the radius of the last tree to block the line of sight requires that we figure out where that line of sight is. Now in our 2 unit orchard, remember we're at the center, 1 unit, that gets us to our first tree, 2 units gets us to our next tree. This allows us to have 1 more tree here, but that's it. There's no more trees that are inside this radius for our 2 unit orchard. So in this case, it's really simple. There's 1 line of sight that's going to go out through here, and there's another line of sight that's going to go out through there. There's no other avenues for a line of sight to leave the orchard. So here's a little trick. I'm going to analyze it from this part here, knowing it's the same as that, so we're going to focus on this one. This line of sight is going to pass through this last point. Now that point does not represent a tree because there is no tree there in our orchard, but the line of sight will pass through that point. So I can go ahead and get my straight edge out just to be exact if I like, and I can draw that line of sight. And that's our last line of sight in this orchard. LOS for line of sight. So now we need to identify the trees that are going to touch that line of sight last. So this tree is pretty far away from the line of sight. This tree will touch that sooner, as is this tree. This tree could touch the line of sight, but again, these 2 trees are going to touch that line of sight sooner than these other trees. So they're the trees that are going to create the hideout situation for this orchard. Next step, draw those trees at the moment they touch that last line of sight. So I'm just going to draw that tree there, and that tree there. Now my drawing might not be perfect, but it's good enough for our purposes. Notice also how these trees are not touching. They block the line of sight well before they touch. Okay, so now we get into this geometry. Now remember, here's the radius of that tree. It makes a perpendicular to the line of sight, and we need to figure out what is that length. That's the radius of the tree when it turns this little 2 unit orchard into a true hideout. That is that moment that when we're standing at the center, we can no longer see out. That's what the hideout is. So we have to draw some other stuff on here to figure that out. So what I'm going to do, let's use the red pen this time. I'm going to make some triangles. My first one is like that and like that. I have a 90-degree angle right there. And what my thinking is that I'm going to try to use SOHCAHTOA, standard basic trigonometry, sine, cosine, and tangent, to figure out ultimately what that tree radius is in this 2-unit orchard. But if I wanted to use SOHCAHTOA on this little triangle, which I could because I have a right angle, I need to know something about it. Well, let's take a look. What might I know? I do know that distance. That's 1. So I'm kind of maybe there or close, right? To use SOHCAHTOA, you need to know 2 things about a triangle, and then you can find out a 3rd side or an angle or something like that. Well, do I know anything else about this triangle? If you're like me, you don't see anything else. I know this side, which is my hypotenuse for this kind of upside down right triangle, but I don't know anything else. I don't know that angle, and I don't know this side either. So I don't have enough information to use this little mini triangle to find x right away. So now I'm going to step back for a minute and take a look at this triangle. This one's a much bigger one, and let's take a look at what we might know about that. How about this distance here? We know this part's 1. We know that's also 1. So the length of this side is 2. That's nice. We're getting somewhere. We still don't know that angle. Darn, can't do that. But take a look. There's one more thing that you know. Pause the video and see if you can figure that out. Okay, if you notice that this distance here is also 1, you're right. So now I have 2 known sides in a right triangle, which means I can find out the other 2 angles using inverse trigonometry. So let's take a look at how that works. And if SOHCAHTOA trigonometry and inverse SOHCAHTOA is like all Greek to you, or it's so rusty you don't remember it, I have some videos, they're on the weekly planner, that you can, I would strongly recommend you take a look at those so you get refamiliarize yourself with how to use trig to find sides and angles in right triangles. So for those who know, you're going to recognize that I now have a way to find this angle, and once I know that, then I can find my x. So here's the thing. I'm in the angle I want. I look out in my triangle, and I realize that I know the opposite, and I know the adjacent. So in SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And tangent's going to be our function because the angle I want is here, and I know the opposite and I know the adjacent. I'm going to give this angle a label so we can start talking about it. And we're going to use theta. Theta is a really common variable for angles. And now I'm going to write my trig equation. Tangent of theta is opposite over adjacent. So tan theta equals opposite, which is 1, over adjacent, which is 2. So tan theta equals 1/2. So I know what tan theta is, but I don't yet know what theta is. So this is where we use inverse trigonometry, and we rewrite this equation like so. Tan inverse of 1/2 equals theta. And that's how inverse trigonometry works. Let me go grab my calculator. I'm back, and now I'm going to plug that into my calculator and just do 1/2 second function tangent, and I get 26.6. So theta equals 26.6 degrees. Okay, so now I know this, theta equals 26.6 degrees. So what I did is I used this bigger triangle to figure out something here, this angle, which is also an angle in this smaller kind of upside downish right triangle. So we're halfway there. Buckle your seatbelts, let's finish this up. So now I'm going to drill into this little triangle, and I'm going to go, I know theta now, and I know this side. What is that side? Well, it's opposite of the right angle, so it's got to be the hypotenuse. So I know theta, and I know the hypotenuse. I just don't know x. And what is x? Oh, x is opposite of theta. So now I know the hypotenuse, and I want the opposite side. Which trig function deals with the opposite and hypotenuse? That would be sine. Sine is opposite over hypotenuse. So now I can write a standard trig equation because I know my angle. I can write sine 26.6 equals opposite, which is the one I want. That's my x over hypotenuse. X over 1. Now this is going to simplify down nicely. What's x over 1? Just x. Anything over 1 is just itself. So that tells us that our x is just going to be sine of 26.6. Do sine of 26.6, and I get 0.447. So let's round that to 0.45. So x equals 0.45 units. And there you have it. We did this trigonometry, geometry stuff. We started with our diagram, correctly drawn hideout trees. Mark the radius of the tree when it touches that last line of sight. Then use tangent to find the angle we need that's in the smaller triangle that includes the radius that we need. Then we use sine to find that radius, which we mark as x, which is 0.45 units. Right now we don't know what the spacing between the trees is, so we're just calling it units. So this is 1 unit there. This thing is 0.45 units. And there you have it. Now when we do a 3-unit orchard, the calculation will be fairly similar. And in fact, this calculation is going to carry you all the way through to the solution to the unit problem. And if you're in my class, you should be able to do this calculation for probably any size orchard, because you'll see that on our unit test. A 5-unit, a 10-unit, a 7-unit. I could give you any one of those on that test, and you would need to go through very similar steps to find the radius of the last tree to touch the last line of sight. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.